Hey, so today's lesson is going to cover solving quadratics by the square root method. Your learning goal is I will be able to solve quadratics, you guessed it, using the square root method. Now, we've worked with our square roots and cube roots in previous units, and we've also done some work with quadratics when we did some factoring earlier, but now we're going to put some previous concepts together. In this particular lesson, we've got a vocabulary word, principal root. You may find tons of definitions out there. This is a abbreviated version. It is the positive root. It's the positive root. So when you take the square root of something, it can equal plus or minus a number. And the positive root, so in this case, positive 7 is called the principal root. Negative 7 is a root, but it is not the principal root. So if you need to, go ahead and pause and get your vocabulary written down. Now here is a slide. You need to know the difference. I said know the difference. Repeat after me. Know the difference. You have to know the difference and how to attack each of these quadratics when you're trying to solve by square roots. They all have the squared, which makes them a quadratic, but the order in which you are able to do your steps does matter. So you can go ahead, take a moment, pause the video, pause the video. I highly suggest that you copy down this slide in its entirety because I can guarantee on assessments, you will see at least two of the three types, if not some variation of these in your work. So pause it and copy it. Okay, great. So now that you know the difference, we're going to work through each of those examples from the know the difference slide, and then you guys will have your own to try on your UDO slides. So this one says x squared minus 7 equals 9. It tells you here in the steps that you can do SADMAP, which again is your PEMDAS backwards. You have to do that first. So SADMAP, we got it. Let's check it out. You ask yourself, hey, do I see any subtraction? Oop, I do see subtraction. So what is the opposite of subtraction? The opposite of subtraction is addition. So I would add 7 on both sides. Don't forget to draw your wall through the equal sign so that you can give yourself that visual of what's one side versus what's the other side. Now, after this step here, you go ahead and cancel and combine. Those 7's cancel, and 9 plus 7 is 16. Bring down your x squared. So we've completed the first set of doing PEMDAS backwards, the SADMAP. Now notice that when we're going through our SADMAP, do I see addition? No. Do I see division? Nah. If I don't see a fraction, then I don't see division. So no. Do I see multiplication? Do I see E for exponents? I do. I have an exponent of 2. The only way to get rid of the exponent is to take the root of that exponent. So in this case, I have a 2, so I take the square root. If it was a 3, then it would be the cube root. But again, we're dealing with quadratics in this unit. So take the square root on both sides. Bada bing, bada boom. Remember, the opposite of squaring something is the square root. So those cancel each other out, and I'm left with x equals, but don't forget the plus or minus. Don't forget the plus or minus. So you got plus or minus. What's the square root of 16? 16 is a perfect square. What number times itself gives you 16? You got it, dude. 4. So your answer is x equals plus or minus 4. What does that mean? It means that x equals positive 4 and x also equals negative 4. So either one of those you could substitute in and you would still get the same outcome. Pause the video as needed, and you know what's coming up. You do. So go ahead and pause the video. I said pause the video. This time you're going to try to solve this problem all by your lonesome. So give yourself about 2.5 to 3 minutes on the clock. Use that previous problem from the we do to give yourself a best shot effort at knocking this out, and come back in about 2.5 to 3 minutes to see how did you do. Did you get it? Did you get it? Hey, did you get it? So in this case, what I want to highlight is the square root of 7 is not a perfect square. Square root of 7 also cannot be broken down. 7 is a prime number, so there are not any perfect squares that go into 7, so you could not simplify by the perfect square method. Also, if you were to break it into prime numbers, the only way to get 7 is to do 1 times 7. There are no pairs to kick out, so therefore you just leave it underneath the radical, but it's still plus or minus 7 as your answer. All right, so we're going to pick it back up together. You know I wasn't going to leave you hanging too long. Now, this is our second example from the Know the Difference slide. And what I really want to draw your attention to here is that very first bullet point where it says the x minus 7 is in jail. I use quotations. So you cannot just start off by adding 7 on both sides. Those parentheses and that exponent, that's like, parentheses is like the jail bars. The exponent is like the guard, the prison guard. Like, you can't just go up there and be like, hey, free Ray Ray. You can't do it. All right. You got to break Ray Ray out fair and square. Same thing here with the problem. So you cannot start with that -7. You do have to, in this case, take the square root on both sides first, because there's nothing else for you to move over to the right side of your equation. So we said we're going to start by taking the square root first on both sides. We know that the opposite of squared is square root, so those will cancel each other out. Now we have officially broke Ray Ray out of jail, and now x minus 7 is there. Square root of 9, square root of 9. Well, when we take the square root of both sides, we know that we still have to put that plus or minus sign there. But square root of 9, 9 is a perfect square. You can't take the square root of 9. And what number times itself gives us 9? Yes, sir. You got it. Thrizzy. So plus or minus 3 on the right-hand side. But we are not finished because x is not by itself on that left side of your equal sign. So the next step tells us, hold up, swole up. If it is a perfect square, which the square root of 9 did come out perfect, you're going to go ahead and split this into 2 different equations. If you don't split it into 2 different equations, you're going to end up getting the wrong answer. Okay, so let's split. Plus or minus equals a perfect square. We do have to split because there's going to be 2 different numerical outcomes, 2 different calculations. Split. What do I mean by split? You're going to split it into one positive version and one negative version. The only sign that changes is what comes after the plus or minus. So I have one version that equals positive 3, and I have one version that equals negative 3. No other signs change. That's it. So don't go messing with that x minus 7. That stays the same. That's like your principle. That's like your solid thing. It should be the same in both of your equations. The only thing that's different is you have a positive 3 and a negative 3. From here, you then do your SAD map again until you isolate the x's in both of the equations. Now, the beautiful thing here is your step will be the same for both sets of equations. The opposite of -7 is +7 or +7. So you add 7 on both sides in both equations. The steps should match, but that calculation better be different. So yes, I know that those 7s cancel out in both of them. Beautiful. However, 3 plus 7 is going to give me a different answer than -3 plus 7. And if you don't know, you better ask your calculator. So x equals 10 and 4. X equals 10 and 4. All right, you know what's next. You gotta do what you gotta do. So go ahead and pause the video, pause the video, pause the video. Give yourself 2.5 to 3 minutes on the clock. Come back in 2.5 to 3 minutes to see how you did. I believe in you. You got it. Oh my gosh. Did you get this as your answer? If you didn't, I'm almost willing to bet that you forgot to split your equation into one positive version and to one negative version. Or if you split it, you ended up changing a sign that didn't need to be changed. See how I read your card and I didn't even have to see your paper? I know. It's a gift. All right, so go ahead and pause the video, make any corrections that you need to make. And the next one we're going to do together. Okay, we do another one together. Now, yes, we still have the x minus 7 squared. That's still technically in jail, but that's not the very first thing that we are going to take care of. We cannot just jump right in and do the square root on both sides because we have not isolated the square term. You can only take the square root on both sides once you've isolated the term that has that exponent of 2. If there's anything else on that side of the equation that does not belong with that exponent of 2, you have to get rid of it first. So in this case, what does not have that exponent of 2 connected to it on the left side of the equation? That plus 1 has to skedaddle. So we're going to go ahead and do our SAD map, which is our PEMDAS backwards. Do I see subtraction? Yeah, I do. X minus 7, but guess what? That's in jail, so I'm not talking about that right now. Do I see addition? I do see addition, okay? I do see addition, reminding ourselves that that X minus 7 is in jail, so I can't touch that subtraction yet. So I deal with the addition. What's the opposite of addition? Subtraction. So you subtract 1 on both sides. Draw that beautiful wall through your equal sign so you can clearly see your left side from your right side. Those ones are going to cancel out. I bring down the x minus 7 squared. And what's 9 minus 1? Yeah, 8. Now from here, we are not done. We have isolated the square term, so our next move is to take the square root on both sides. How do you get rid of a square? Take the square root. Take the square root on both sides. When I do that, remember squared and square roots cancel each other. Don't forget the plus or minus. Now, the square root of 8. 8 is not a perfect square. 2 times 2 is 4. 3 times 3 is 9. Oh, 8 is not a perfect square, but 8 can be broken down because 8 is not a prime number. So remember that. So yes, we got plus or minus the square root of 8, but we cannot leave it there. We have to go back and use those skills that we learned in a previous unit on simplifying radicals. Okay. Before we simplify our radical, though, we are going to go ahead and isolate our variables. So we're going to get x by itself, but don't forget, we still have to come back and simplify that square root of 8. Going back through my PEMDAS backwards, do I see subtraction? I absolutely totally do. Opposite of subtraction is addition. Yes. So we're going to add 7 on both sides, but notice where I put it. I did not put this plus 7 underneath the square root of 8. Those are not like terms. I cannot just simply sit here and combine them and put them together. I strategically put that plus 7 to the left side of my plus or minus because that's where it belongs. Now, x equals 7 plus or minus the square root of 8. If 8 was already simplified, then this would be my final answer. However, 8 can be broken down. I must break down my 8. I have to simplify. So I'm going to simplify my square root of 8. Remember, we had 2 methods, the perfect square method, and we had the prime factor method. Whichever method floats your boat, do what you got to do, boo-boo. Do you. So perfect square method is going to be on the left where you see square root of 8, or you could do the prime factor method, which will be done on the right side. Either way, when you break this down, whichever method you prefer, you should have this. The square root of 4 is going to be 2. In the prime factor method, we circle all of our prime numbers, write them underneath the radical, kick out what we need to kick out. No matter which method you use, you should have simplified the square root of 8 to 2 square roots of 2. Now, how does this go back into our final answer? just like this. So we replace the square root of 8 with 2 square roots of 2. Nothing else changes beyond that. Now, somebody may be asking, hey, but could I have simplified the square root of 8 first and then added 7 to both sides? And the answer to that is yes. If you want to simplify a radical first and then come back and finish isolating the variable, you could do that if that's what you choose to do. We just tend to try to get the variable by itself and then work on simplifying that final answer. But whatever floats your boat. Pause the video and write down anything you need to write down because you know what's coming next. You're gonna do it by yourself. Set a timer for 2.5 to 3 minutes. Come back and check and see how you did with it. All right, I know I won't quit my day job. However, please do pause the video, give yourself 2.5 to 3 minutes to try this in your notebook and come back and join me to see just how close you were. All right, so I gave you everything I had to give you. You should have ended up with the square root of 75, but 75 can be broken down using either the perfect square or the prime factor method. You did need to add 9 to both sides, but remember, you are not combining the 75 and the 9. They are not like terms. The square root of 75, that 75 is like in jail. You cannot do anything with it. Okay, not with the regular number. So stop making up your own math and putting things together just because you see numbers. All numbers cannot be combined. All right. So pause the video, make any corrections that you need to make, and I'll see you next time.